And thank you for coming to tonight's job user group meeting. My name is Jim Bethencourt. I'm the host, and thank you, Scott Worsham, who's helped organize this meeting, and thank you, Billy Korando, for coming all the way out here. Really happy to have everybody here tonight. Thank you all for joining us. Improving is the meeting sponsor, they've graciously opened the doors to host us and provide us food and sodas. So if you want a soda, feel free to grab one in the fridge there. Help yourself to more pieces. It looks like there's some more left. And we do have a user group space available. So if you'd like to start a user group, or if you are looking to participate in other user groups, we have a free code camp. I think it's called Code for Y'all now. And then also we have a .NET user group. They're meeting here tonight as well, in across the way. And then we also have something really cool called the Side Project Society. So if you have a side project and you want to get input from other folks or feedback on how it could be better, it's a great place to do that, or just to learn about the cool side projects that other people are doing. Have used some product community, and I think that one is defunct now. I think that it had its last meeting a month or two ago. The Analytics user group has been renamed the Houston Open Source Society, and they meet once a month as well. And then the Houston Job user group, of course, is this group. But yeah, if you have an idea for another user group, let me know, and I'd be happy to put you in touch with the right folks. And also we are taking resumes for Java developers, DevOps folks, senior .NET developers, business development managers, agile coaches, and account executives. I know particularly we're looking to hire someone with QA background, I believe. And also folks, if you know Python and Databricks, I'd like to talk to you too. We're definitely looking to hire somebody to fill that role. And so otherwise we are taking resumes, but we don't have a whole lot of openings right now as far as I understand. I think we might have a job opening actually. So I can certainly reach out to pass along to the recruiter and see what we can do to make happen. And then yes, so as I mentioned here, some of these have been filled, but the Databricks architect, I believe we're still looking to fill, and also the sales account executive. So if you know somebody who is really good with sales, let me know. We're looking to hire somebody strong in sales. And then if you're looking to learn Scrum more, learn Agile, how to be an Agile developer, Improving is the largest provider of Scrum training in North America. We have trainings constantly. If you go to improving.com/training, we have a full calendar of Scrum trainings available. It's quite extensive. And again, if you're looking to just learn about Scrum, we have PSM1, Personal Scrum Master 1 classes available at least every other week, if not every week. So, and also many are available online as well. So you don't need to come into the office or be at a specific place. And they're great, really well taught, great material. And you can call your Scrum Master out if they're not following Scrum. So, what else? So please take a moment to sign in with your phone. I would really appreciate it. It helps us to continue to be able to have meetings here. Definitely, if you could take time to do that, I would really, really appreciate it. All right, everybody got a snap of that? Awesome, thank you so much. And then certainly last but not least, you got that? Everybody got it? Everybody else sign in? Okay, cool. And then last but not least, this is this month's door prize. Right here, let me move this out of the way. That's that way you can get a snap of that. So go ahead, and that says so you can register for door prizes tonight. Right, so make sure, because if you don't get it, you can't win. All right, okay, I think that's about it. Anybody not get the QR code for door prizes? You wanted to? Nope, okay, all right, cool, very good. Well, thank you so much. Anything else, Scott? Use Java 25.
Yeah, make sure you got your latest job.
Exactly.
Billy will tell us about that.
Yeah, all about it.
Cool. All right, well, thanks so much. Take it away, Billy.
Perfect, thank you.
My pleasure.
Door prize.
Oh. Okay, just a moment, I'll make my way over there. There you go. Oh, anybody else? Okay, cool.
Fantastic. All right, yep. Thank you, Jim and Scott, for inviting me back down again to come here and present at the Houston Java Users Group. Yeah, actually, so one of the things I've been kind of doing over the past year or two, is doing like little tours of various Java user groups. So I started in Tuesday up in Oklahoma, Oklahoma City Java Users Group, then I drove from there to Dallas, and then from Dallas to here. So yeah, it's fun. Yes.
Can you share your screen?
Oh, yeah, of course.
Just so-
Yeah. Like, this is
So
the
those
first time I've ever
online
done
can
this
see.
stuff before.
Bro, do you even present?
And
Then you just gotta minimize all that. Yeah, there you go.
perfect. Okay. And,
Yeah, don't look at me.
Exactly. Okay, yeah. There you go, now that everyone can actually see as well. So yeah, but there's always a great opportunity to get to see all the various Java user groups around the country. So, yep, I'm gonna be talking about why developers should love testing. This is kind of like uh, and so I'll touch a bit on the presentation, but this is maybe even something that Jim is maybe a bit familiar with. Before becoming a dev role, I worked at like one company for a number of years, like about 7 years, and I worked at a few other companies also as a consultant, working with a number of other companies. And I noticed like a lot of these different companies, they were oftentimes very out of date. Like they decided like we are on this specific version of Java, like not just like Java, like 21 or something, but like we're on 21 dot whatever, like and we're just staying on that one, or we're on this specific versions, the patch number a spring, and they just kind of stayed there. And I'm like, what, I was trying to figure out why that was. And this kind of presentation is a bit about that, about why developers should love testing. And we'll kind of get into how this relates to projects that get out of date. And yes, my name is Billy Korando, Java developer advocate from a little company you might have heard of called Oracle, but don't hold that against me, I'm otherwise an okay person. Please feel free at any point to ask questions about during this presentation here, to talk about testing. And if you have any questions, by all means ask. The point is for you to learn about this stuff. And if I'm not covering something in enough depth, or you think I'm just wrong, by all means, we can talk about them and have a discussion. That often makes it for a much more interesting presentation for everyone. Feel free to reach out, email me at billy.crandall@oracle.com. Also feel free to reach out on LinkedIn. I actually need to kind of update this presentation to include my LinkedIn on there. And if you want to link to this presentation, or you want to view this presentation, you can just go to this very link on here, and I'll take you exactly to this presentation. As you can see, I'm at that URL as well. So there's also a bunch of different ways you can learn more. So we have dev.java. Of course, you're already here, but one of the nice things we have on the dev.java is we have a community section where you can see all the different Java user groups that we know about across the world. So if you're interested in presenting or something, of course, maybe start here with your own Java user group, but you can also find some other nearby Java user groups around and reaching out to them. As Jim and Scott know, finding speakers is always a bit of a task. So certainly almost all Java users groups are going to be very happy if someone reaches out about presenting. If they haven't found a speaker for that upcoming month, I'm sure they'll probably find you pretty soon for some other speaking slot. But along with dev.java, we also have a bunch of articles and tutorials covering, learning various Java concepts or new language features. Insight.java is a good place to go to kind of keep up to date on whatever the latest stuff that is happening within Java. So whenever like some of our JK engineers, they may put together like an article like covering some new features, like so for example, like the new we did like a new EA release build of the project Valhalla, which is like a project that's about adding some advanced language features. I think we had like an article kind of covering some of those changes in there. And then finally, our YouTube channel, which is a really great place to go. We release, 3 or 4 different videos every day, or not every day, every week. Covering various Java subjects for both keeping up to date with the latest and as well as we'll cover basics and other important features that maybe aren't covered enough. And lastly, our Java podcast. I guess one other thing, I need to update this presentation with that, but we're also bringing back Java 1 again this coming year in March. So it'll be March 17th through 19th. Registration is going to open up here, I guess at the start, our December 1st. But
Call for papers is closed.
we just extended it for a little bit longer. So if you wanted to submit, like definitely like make sure to submit like by tomorrow or something
Yeah,
like that.
yeah.
But let's see, but yeah, so we ran Java 1 earlier this year back in March and it ended up being a success. And I don't just say that because I was a part of it, but there was a times I was legitimately going to be concerned that the number of attendees there was going to be very low, like the number of speakers was going to outnumber attendees. Or it was going to feel very corporate, but it wasn't like that at all. It was actually really good. We were aiming for maybe about 500 people overall, so not too big of a conference, but one of the nice things also with it not being too big is that you also get an opportunity to actually interact with the JDK engineers, actual people who build and write and design the Java language itself. So if you actually ever wanted to, kind of talk to some of those people, this is a really great opportunity there to do that. So I'll be there. Of course, and along with, again, a bunch of the other JDK engineers and a bunch of other people working and contributing to Java. And the ticket prices aren't too bad. I think they're gonna be about like 400 to 500 or so. So it's not like gonna break out of your bank or more likely your organization's bank to perhaps send you there. Granted, the flight and hotel would also be something as well. But anyways, let's get into this actual presentation. So we're gonna cover 4 major topics. First is why you should be writing tests. Then you need to writing tests you love. How can you tackle particularly writing reliable integration tests? And then finally, some additional tooling options as well. So why write automated tests? So we've all hopefully at some point written at least a few automated tests and stuff like that. And maybe you read some articles and books out there. But why should we take the time to write these? It can't just be, oh, it's a best practice or
Because I want to sleep at night.
yeah, exactly. But we can't just say, oh, it's a best practice, or we can't just, have it just be like, some very high squishy thing. Like there has to be some practical benefit because writing automated tests, particularly, a really robust automated test suite, that's going to take a lot of time. In fact, really, the amount of time you can spend writing automated tests will almost certainly easily outweigh the amount of time you're actually spending writing quote unquote production code, the actual code that it's going to be executing in production. And then of course also the amount of time it takes to maintain a robust and comprehensive automated test suite can also be pretty substantial because whenever you go in and make some sort of change to the code, well, that's going to mean you're going to have to go and update those automated tests as well. So there has to be some real benefit to this. There has to be some way you can go to a manager and really explain if they're skeptical why you're taking the time to do this. Like I said, as mentioned, substantial time and effort commitment. And so, yeah, and then all this time you're spending maintaining or writing tests, that's time that you're not spending on writing production code. So again, we can't just do best practices. Yes, Jim?
So what about AI? I mean, is testing, are the testing commitments that you mentioned here as relevant in the age of AI?
I absolutely, I mean, AI, it's made by humans, so it's gonna be fallible. Certainly, I think in many more cases, it's much more fallible than, a more senior developer. So even though if you maybe having AI write the code out, you would still, of course, want to test it. And even if the code written by AI is initially perfect, just because it's perfect at, here on November 13th, doesn't mean that it's gonna not have some sort of issue in the future. There could be some new security issue that comes up, or as you update underlying libraries. That's gonna be, something where that code needs to be updated, or of course, business requirements will change.
Right, I guess specifically writing unit tests. In
Oh,
the
right.
age of AI, you have the production code,
Mhm.
and you say, okay, well, I've written all the code. AI, go write the test for me.
So actually, that's something I'll kind of touch on a little bit later.
Okay.
With the
Okay.
additional tooling, so, but yeah, that is a good point. But at least getting back to, the automated testing is that, so one of the things I was kind of was the initial impetus, and kernel that kind of started this presentation is when I kind of learned about something called continuous delivery, or continuous integration and continuous delivery, continuous deployment. Are people kind of familiar on some level, kind of with those concepts? If you're not, at least ultimately continuous delivery is the idea of when you commit code to your GitHub repository or to your repository, that's going to kick off a set of automated steps that eventually is going to, push it out to production. Not necessarily that every time you commit code, that's going to go out to production. Maybe you do have some sort of manual thing to say like, okay, this code goes to production. Like you don't maybe necessarily want to bring down production during like business hours. Maybe you wait until, off business hours or something, but otherwise it's not some sort of manual check. Of course, if you do that though, the only way any of these automated deployment process is going to work, the foundation on which they're going to be built is automated testing. No business, for any application of any sort of meaningful business values, they're not going to be like, oh yeah, of course, Billy, yeah, you can make code and we'll just push that out to production without any checks. That would obviously be madness. So the only way any business is going to agree to do that is if you have some amount of automated testing there that verifies the correctness of the code before it goes to production. So there's some amount of confidence that we're not going to be pushing bugs to production that, could, cause severe issues, could lose money, lose reputation, security, and so on. Automated process, the foundation is built upon is automated testing.
So maybe one question might be like, what was life like before JUnit, before SUnit?
Yes,
So
so it was painful. So I actually, in fact, remember, and again, this is going back to like the first company I worked at. So I started as a developer in January of 2008, and we effectively had either literally no or effectively no automated testing at all. And in fact, the way we would deploy to production, we didn't even have anything like CI or anything. What we would actually do is go out, pull down the actual production artifact, unzip it, and then manually add the specific class files that we changed into that, and then put the artifact back together and put it out to production. Needless to say, that can occasionally lead to some issues in production. And even later on, like we were never at that organization, never that good with automated testing. At least when I was there, they were never that good with automated testing. There would be fairly often a case of a bug getting to production, and certainly led to a lot of sleepless nights for me when that happened. And also the process of getting to production was very painful. So like we would only do, I think we did maybe, a quarterly push to production. So like every 3 months is when we would actually push a new version to production. Of course, there might be in between there when we were doing some sort of production of bug fixes, but as far as actual new features or pushing to production, it was only once every 3 or 4 months. And that's because it was a lot of work, because I would do my code, I would make the updates, and then I would manually test it on my laptop or whatever. And then we would push it to some like integration or QA region, and then we would have the QA department, they would manually go through and test it all. So it was all extremely labor intensive. And then this is also going to about to get here into my next point, is that because like I and my other developer colleagues and the QA testers, like we're all spending time testing and working on the code that like I wrote or rewrote and then all that. So to me, like maybe kind of in my mind, like I thought like all the code that's actually running on production was predominantly my code, like, the code that I wrote myself. But the actual reality is the code that you write and that's actually running on production is just the little tip of the iceberg, the metaphorical iceberg of what's actually running out there. The vast majority of the code that's running out there is the underlying dependency. So whether you're using Spring, Quarkus, Liberty, whatever, underlying framework, that is bringing a whole bunch of stuff. And then from that, there's its own libraries that it's bringing in, like again, like
All the
Spring.
abstractions,
Huh?
all of the abstractions.
Yeah, all the abstractions, all those libraries, like your, whatever your Jackson or JSON library, your application
All the
server.
stuff you used to have to write when Java first came out.
Yeah, exactly. So all that stuff. So, and then of course, the JDK itself is under that. And then, of course, the operating system below that. So all that stuff is all out there running in production. And of course, particularly from security, that is where the vulnerabilities would lie, that, a hacker out there doing that stuff, looking for vulnerabilities, not looking for necessarily an exploit in the code I wrote myself, though, there could be some cases with like SQL injection that, like, if I'm just taking like a raw string from some, field and passing it in, maybe they test for something like that. But most of the time, they're going to be looking for like, okay, what version of the application server I'm using, what version of, these underlying libraries. If they can find a way to figure that out, they can be like, oh, okay, you're using Spring Boot 3.3.1. Okay, well, there's all these known vulnerabilities for, this out of date Spring Boot version. And then sometimes you can just copy and paste from sites the ability to exploit that. So
Oh, yeah.
security vulnerabilities are particularly going to be in that area. And then, of course, beyond the security side, performance, if you want to improve the performance, chances are from like just updating your dependencies, you can get a performance improvement. Certainly if you update your JDK, you can get oftentimes a performance improvement just from doing that and making literally no changes. And of course, also new language features or new features that come out both at the language level, like JDK or whatever libraries are using, they're constantly also adding new features. I also remember distinctly at times, like when working on some of these applications, particularly again, at my first company, I'll be like, oh, this is really cool. Oh, I can't do that because we're on, a major version behind whatever I saw this thing on Stack Overflow or whatever. But yeah, but this was a constant thing I was seeing though, is that, a lot of these different organizations I was working at is that they were often very far behind whatever the latest of whatever was. And oftentimes, again, it wasn't just we weren't behind on the major version, we're behind on the patched versions as well. So like we weren't even keeping up to date security. So it's like, it'd be one thing if you're still on JDK 8 right now, hey, get on JDK 25, definitely. But at least if you're keeping today with the patch versions, at least you're more, as reasonably secure as possible, while still being on JDK 8. But like oftentimes, again, we would be like on some very specific version of Spring Boot. Like I remember like we were like at one organization like on Spring Boot 2.5.2 and it'd just be like we wouldn't update that. And so the reason I was trying to figure out like, okay, why wouldn't we update these dependencies? And that's because we were doing a very manual process. Again, I would write the code and then like I would do testing on those changes on, again, my local system or maybe some development region. And then once I'm like, okay, like I feel confident about this, I would promote it to like our QA region. And then we would have manual testers go in and then check and verify that code. That's obviously a very high effort. And that's just when I'm doing it for like, hey, I updated this page, I updated this field or whatever, that can be like, okay, we can go and quickly test that and, make sure it's all right. But if we're updating dependencies, well, really you would have to do a manual regression test to make sure that that all works, because you can't really say how these underlying dependencies might affect your application. I mean, sometimes, be like, oh, this is critical security flaw, like we'll push that in whatever. But as far as like, hey, we just saw this new patch version of like one of our 20 different, libraries out there. Hey, that if you're having enough libraries out there, you'd be constantly having to do updates, and you're not going to be constantly having a QA department doing manual regression testing, because that obviously takes a lot of time and a lot of money and a lot of effort. So ultimately, that's why a lot of these organizations, they were so far behind, is because there was this powerful disincentive to keep up to date of the requirement to manually test to make sure you weren't accidentally introducing an application. And that's where the automated deployment process comes in. If by allowing it to where, oh, okay, we're updating this dependency and it just only kicks off this automated process, the marginal cost of that is extremely low. So keeping your code up to date becomes a lot more easier, a lot more practical. Now, there might still be some reasons because, you know, updating it might require refactoring code and stuff like that, that you can't always do that, but it becomes a much more practical thing. There also are other additional benefits beyond just keeping your code up to date. Because you have a fully automated process, it becomes actually much more auditable, you know, again, when I talk about continuous delivery, so one of the two people kind of codified it, Jez Humble and David Farley or something like that, David Farley. But I saw like a presentation from Jez Humble, and he was talking about how at various organizations, like after writing this book out, he started consulting with various organizations on improving their automation. And like sometimes some of the pushback he would get from like managers is kind of like, oh, well, if it's all automated, it's going to be all black box. Like we have no idea what's going on, why we're going to lose control. But the reality is an actual automated process is actually vastly more auditable. And this is also particularly important if you're a highly regulated field, like if you're in pharmacy or finance or something like that, banking, that, auditing, like there can be very specific legal requirements you need to follow. But really automated stuff is vastly more auditable for that to make sure you're meeting regulatory requirements, or just also making sure you're meeting whatever internal requirements you're meeting. So of course, when you write your test, you can actually review a test to make sure that it's meeting whatever requirements that make sense for your organization. So I write my test out, you can go read that test and say like, yeah, it is actually checking these code. It's doing these things that are making sense, whatever parameters that we need to check. Of course, you can get reports back as well, saying like, yep, these tests are being run with every push to production, or are being run at whatever cadence that makes sense. You have logging, so like, yep, we know this test, it says it ran, and we can see logging from the system that says like, if when this ran, we got a response back from the system showing that this all actually happened. This is in comparison to a manual process that if I would, I can't tell you the number of times when I made some sort of change and then I tested to make sure the change worked. And I'm like, oh, wow, yeah, I fixed that bug, except I either, I thought I pushed it to a region and that push failed, or I was testing in a region and I was testing in the wrong region. Or there could be some times where I thought I did something, but I actually didn't. Like maybe when going through a bunch of fields, like I accidentally fat fingered and hit the space bar. And so like, that field wasn't empty, or did something like I wasn't, inadvertently doing that then caused that test to no longer be correct and could give a false positive or a false negative or whatever it might be. You can't get literally into a person's brain and to know what they did. They can sit here and say and fill it out paper like, yep, I did this test. But there's, no easy way of validating that. So an automated test or automating it is, again, much more auditable, which can be good for a lot of organizations. And of course, it's repeatable. Humans, of course, we get bored, we get whatever. So like, we're not going to always maybe want to run a test the exact same way every time. But with the automated test, you can just retest something, and then that can also be a way of verifying like, okay, hold on, we ran this test, it failed one time, we ran it again, it didn't fail. You probably want to fix that, a flickering test like that, and we'll get to that. Also depending upon how you write your test. A lot of times when I write written tests, like I keep it all in the same repository, so it might not be easy to run your test against older versions of code, but if you were maybe keep it in a separate repository, you'd be like, hold on, let's deploy like an older version of this code and then run our test against it to see what happens. The test maybe when a bug was potentially introduced. But that could also be an option as well. So also a question that often comes up with this are, is often talked about in a lot of blog articles is how many tests should I write? You know, what level of code coverage should I get to that says that, yep, that's enough and we can go to production? And the way I say it is that fundamentally, I can't answer the question, and any sort of metric I think is flawed. What it is whatever gives you confidence to deploy to production without some sort of manual intervention. And again, when I say manual intervention, is some person going through and verifying the correctness of the code before it goes to production. And I say this because it's gonna vary depending upon the application you're running, the kind of organization and business that you're in. That, you know, if I am writing, you know, for like that, the project you're talking about, Jim, for like how you can finding projects you can contribute to an open source. You know, the cost of having something go wrong there is pretty low. It would be just like, oh, like you can contribute to this project, but maybe they're not looking for contributors. Like the cost of that is pretty low. So you wouldn't necessarily, you know, maybe for other reasons you want to write a bunch of automated tests, but like you wouldn't necessarily need that versus if you're doing pharmaceutical testing.
Right.
Well, of course, like, you know, there are along regulatory reasons, you know, the fact that you could seriously hurt or kill someone if you get something wrong,
Yeah.
that would make it much more important to have a much higher level of code coverage. So like there is no single thing, you know, like get it to 80%, you know, it's just gonna vary depending upon the needs of your business. And oftentimes, again, things like code coverage aren't really super good quality metrics for determining how well you're testing your code. Something we can even get into a little bit later on also how to test the quality of your tests as well.
Yeah.
But yeah, fundamentally, it's whatever gives you the confidence to go to production without manual intervention. That's what you should write it to, and if you shouldn't add more tests afterwards, because now you're just adding additional work for you. And maybe you also find out that maybe you have too many automated tests for some reason, in which case you maybe need to scale it back at some point. Maybe because it's taking too much effort to either maintain those tests, you know, you're writing a bunch of tests and you feel like, okay, this has very little benefit, so you might as well get rid of it. Or maybe the amount of time, like CPU time it takes to run all those tests is taking too long. That said, I've been saying like a lot of negative things about manual testing, but I'm by no means against the idea of it. I'm against it as a means of verifying the correctness based upon change to it. But manual testing should still be happening, but it should be exploratory in nature. That means it's happening in parallel to development. It's finding things that you maybe didn't realize you needed to test. It's trying to explore finding bugs in your code or something like that, not just saying, I didn't actually introduce a bug when I made this code change. So it will be exploratory in nature, happening parallel development. It wouldn't be part of the steps of getting to production. Okay, so how can I write tests that you actually love? If you can call it that. So I think one of the things, and again, this is also, again, kind of getting back to my own personal perspectives to this, is like when I first started doing automated testing, I'm like, oh, well, it's just test code. It's not going to production. So who cares? And so I remember just being very careless of how I was writing this test code. And then that, of course, made it also very difficult to maintain. So you should treat tests with the same care, quote unquote, maybe as you are, quote unquote, as you would production code. You wouldn't necessarily always want to follow all the same practices. So like, you know, within production code, you would definitely want to follow things like, you know, keep it simple, don't repeat yourself and stuff like that. That might not always be good to follow in testing code. Like sometimes it might make more sense to copy a scenario of a test case, you know, rather than referencing like a single common location, because as code evolves, like some of those underlying scenarios might change. And so having it then to re-split it back out and putting it into two separate test cases could be a bit difficult. So sometimes it can make sense that, you know, copying and pasting test code could make sense. Also another thing with test code is you should extremely highly prioritize readability. I mean, generally you want to do that in production code anyways, but there might be some cases in production code where you don't prioritize it because of performance reasons. So, but generally performance isn't really gonna be usually as critical in testing code as it is in production because of the scales and stuff like that. Of course, always consider refactoring tests as needed. And also remember, just kind of like how we do in the JDK, we're not always adding stuff to the JDK. Sometimes we're also deprecating and removing stuff from the JDK. So a part of being a good steward is also knowing not just when to add, but when also to call and prune and remove. So if there's tests that are providing little or no value, remove them because for obvious reasons. So I've been giving this test for a while now, but make sure you're taking advantage of JUnit 5, and actually JUnit 6 has also recently been released. So at least a bit of my own history here. So kind of like how I got a bit started building my name, presenting was with JUnit 5. So back in 2017, 2016, 2017, when JUnit 5 was being released, like for some reason, no one else in the US was doing presentations on JUnit 5. So I got accepted to speak at a lot of different Java user groups and a lot of conferences that I probably otherwise had no business being accepted to at the time. But I also mentioned it just because JUnit 5 at the time was a particularly big jump up from capability over JUnit 4. And there's also a lot of things from like the extensions API that can really be good if you take some time to build out extensions for your organization that can be very helpful for writing tests as well. And there's other things like parallel test execution which can also, if you have a very big, large, mature automated test suite, executing things in parallel gets substantially reduced the amount of time it takes that to execute. Because if it takes your automated test suite an hour or something to execute, or multiple hours to execute even, that's going to slow down the willingness to, make changes and updates and stuff like that. So maybe execute stuff in parallel that can help it as well. Also, some very nice things like test ordering, like that wasn't really possible in JUnit 4 for when you're doing maybe more integration testing or something like that. Test ordering can be very helpful. So take advantage of it. JUnit 6 is out now. Really, there's not too many new features in JUnit 6. The primary thing behind it was just updating it to Java 17 as the baseline. Also consider using assertion libraries. So again, kind of going back to my own history, I remember when writing tests with JUnit, like the assert equals for like the longest time, like to me, it made the most sense that the test value I was checking for was first and the actual value was second. No, the actual value I was testing for was first and the test value was second. That just made the most sense to me in my head. That's the reverse of what it's supposed to be though in JUnit and when they do the assert equals. There's no objectively correct way of doing that though, but that's just a decision the JUnit team made. And I bring this up though, is that because that obviously made when some test failures occurred, very confusing to understand what was happening. And again, there's no correct way about that. But this is where assertion libraries, my favorite one, has been assert_j. You can write out the assertions in a very English way. It would be assert that is equal to that, assert that, and you would pass whatever value in, is equal to, or is lesser than, or is greater than, or is true, or is false. You would write things out in a way you would actually say it in English as like a normal sentence, which of course made those tests a whole lot more readable. That, it wasn't just like if I was coming back 6 months later, but like completely like, you just joined our organization and I had this test written out, like you wouldn't need me to be like, oh, this is what this test is doing. Like, oh no, you can just look at it and hopefully have a good test name, and then the assertion to be like, oh yeah, that's obviously what this test is attempting to do. And that's also one of the nice things with automated tests is that it can serve as like a kind of living documentation of your application, living documentation, because if you make a change to your application code that causes your test to break, then you would then have to go back and update the test. And that way they can ensure your documentation stays up to date with the current state of your application. So writing reliable tests is also extremely important. So like nothing is more worthless than a flickering test. So a flickering test is like you run a test once, it passes, you run it again without making any changes to your code, and it fails. So, obviously that test itself has no, or loses pretty much all value. But then you also start to lose confidence in the overall automated test suite, because now when you get like a failure back, you'd be like, oh, okay, no, that didn't really fail. Like, Ted told me that the database was actually down right now, so that's why it failed. Go ahead and push it to production, except actually you heard wrong. The database was up at the time. That was trying to tell you that something was wrong, but because you no longer really care about test failures, you push to production and now you have a bug. Or in truth, reality is you just really kind of ignore the automated test. You just do your own manual testing. So it's not too new what I'm about to tell you, but like for a long time though, writing reliable integration tests was extremely difficult. So integration tests, at least in this way, is when I'm talking about referencing some sort of external resource from your actual application itself. So like your database or some sort of web service or something like that. But yeah, particularly like, again, when you're interacting with like a database, data could get out of date, or someone could delete some data or that data conditionless is no longer there anymore. And so like those tests that depended upon that would start to fail. And again, you would just kind of lose confidence in that. So it's actually not too new anymore. About maybe close to 10 years ago now, kind of solely after Docker started becoming popularized. A new library called test containers was developed. And so what test containers, how many people have heard of test containers? So a couple, but that's why you're here to learn. But test containers, what it does is it can set up and tear down a Docker container within the context of your automated test.
Or even an entire Docker compose.
Yeah.
Stripper, so.
Yeah, exactly. Yeah. It could do very advanced stuff now. Yeah, exactly. As Jim was saying, you can even have like entire Docker compose script setting up to have set up a whole cluster of containers if needed. But the benefit of this is, so before something like test containers came around, there's a number of ways you try to do this. One, like you maybe, if you didn't want to rely on like some sort of test database, like you would maybe try to set up like an H2 database. And that was nice. You could run locally. You wouldn't have to do any sort of configuration to your system to get it to run. But the problem is H2 would try to only simulate like your Postgres database or your SQL Server database or whatever it is, but it's only trying to simulate it. It's not a literal Postgres or SQL Server. It's not that. So if you're doing anything much more advanced than CRUD operations, then you could potentially run into issues where the test you're writing doesn't actually reflect properly what is happening in production. So it'll be like, oh, your test passed, but it fails in production. And then you're back to the point of like, okay, well, our automated tests aren't really telling us anything, because even if we pass, we actually fail in production. So like the other ways would be, maybe you would actually have developers, whatever you are running for database or whatever external service, you would just have to have like a local instance on your system. But again, that's not so good, because that requires a lot of effort from developers to maintain that copy on their local system, and then actually keeping that sync with whatever it's like in production would also take a lot of effort. But now, again, luckily we have test containers, and as mentioned, what it can do is set up and tear down a Docker containers within the lifecycle of a test or a test class or whatever whatever length of time you wanted to have run. But the real benefit of that is that, particularly maybe also with your teams, if you're also being very good about putting images reflective of whatever is running in production available out there, you can bring down that actual image of like whatever database or whatever service and have it running within the context of the test. And that way you have a lot of like, this is really what it's going to be looking like in production. And so when the test passes against that, that's going to be reflective of what it's going to be like in production. And because you can set it up and tear it down within the lifecycle of your test, you can always have fresh data with it. You don't have to worry about data getting out of sync or anything like that. And because it's always a Docker container, you're not going to be, as a developer, having to maintain something on your local system as well. So if you haven't used it yet, definitely consider it, because and then one of the nice things about test containers, like it's really pretty easy to use. Like it's not super complex to set up and like it just works. So that's always very nice. So yeah, as I kind of covered here, I always kind of forget that I do kind of bullet point that all out. So something that's often kind of controversial when it comes to automated testing is mocking. Um, and for that, the tool I most recommend is Mockito. I've tried a few different mocking libraries like JMock and PowerMock. And if you love those, by all means use them, but I always found them very kind of difficult to use, whereas Mockito always found it very simple to use, and also it uses kind of a given when then structure to it, which again makes it very readable and also maps on very well. If you want to do something like behavior driven development, that also makes it very easy to do. But that said, mocking can often be very controversial. Like you could like, oh my God, we were using mocks, and then we eventually everything blew up in production. And so, at least the way I interpret it, or what often happens, is that people, when developing a mock, are trying to really simulate what the underlying business behavior is like in production, rather than writing that mock to have that layer that's interacting with the mock, creating a condition that you're actually testing in that layer. So like a good example could be like you may have some weird data condition, like like the primary key, like it's obviously never be null, but you've ran into that in production at some point, and now you need to write a test for that. But rather than trying to set up a database to have like a null primary key to figure that out, just set up a mock that returns a null primary key, and then make sure that your application is handling that condition more gracefully than exploding or whatever it was doing before. Or maybe if you want to simulate like, okay, what happens if the connection times out, like if you have like a stalled connection, does our application know to like, hey, after like 10 seconds, okay, just kill it and then do whatever makes sense, rather than trying to set up your database to just be stalled for 10 seconds, to set up a mock that just waits for 10 seconds and then makes sure your application does whatever it needs to do. So one of the ways I think that can really help explain this then. So a friend of mine, Henri Tremblay, he runs the Montreal Java users group. He put together this article here now from almost 8 years ago, actually 8 years ago, that goes through all the different types of mocks, because like we talk about mocks as a generic term, but there is, I believe, 7 or 8 distinct different types of mocks, like a dummy where it's just fulfilling a dependency requirement, a stub, it goes through all these different kinds of mocks, and that can also help better explain how you should be doing mocks, how they should be used.
It's a well-written article, I remember reading this.
Huh? Sorry.
It's a well-written article, I remember reading it.
Yeah. So I would definitely recommend writing that, because like if you're hearing it, I don't know, I still don't know about this much. At least definitely recommend reading through this article, if that can maybe kind of help explain. It could also through that explain maybe some of the mistakes that you maybe accidentally made when trying to use mocks as well.
Like test container is a modern correlative, we might call it fake.
Yeah,
So,
exactly.
and there's different folks define spies differently,
Yeah,
but I guess spies, some folks say spies are, okay, well, let's make sure that what I was calling worked.
yeah,
Whereas like with Mockito, spy is something entirely different.
okay.
Yeah,
Yeah.
so it's like, if that makes sense.
Mhm.
So, the one thing I definitely caution folks against and try to avoid myself is to not spy on the class under test.
Yeah,
Because you want to verify that behavior rather than set expectations on how that class that you're testing should behave.
yeah. So yeah, exactly. Then I think that's just oftentimes where people would get into trouble with mocks. It's like, that level between what you're testing and what you're just using the mock to simulate also becomes a bit gray. And then that's oftentimes where people run into trouble as well. So, yeah, I highly recommend, again, giving that article a read. Like it's like literally you can read it all. I mean, it's a short article, you can read it all in about 10 minutes. And I think it really helped clarify the concept of it. Another thing, that's also a bit newer, kind of around the same time, a little bit as test containers is starting to become popularized, is contract driven development. And so how this works is that you would write out in kind of code, kind of a contract behind how a client and a server should interact with one another. So like, let's just say you're building out a RESTful client, and you're like, okay, this RESTful client, it's gonna have like an API or a URL, and it's like, okay, if you call, create, new user, okay, that's at this URL, and you call that, okay, the post, like you would need to include like this information. And then assuming you gave me this information, you would expect a response back like this. You can handle this for both good cases and bad cases. So what's really nice about this though, is that, particularly when you're talking about writing out like some sort of new application, is that it can allow both the front end and the back end, or both the client and the server side to kind of actually develop in parallel, but because they're both testing against this contract, that means that they have confidence that once they actually are then referencing the real life service, that both sides can also work. Because, particularly again, using like the front end and back end example, was like they could be working at different paces, like the back end that develop, they might have a bunch of free time, so they're actually maybe able to make a lot of progress, whereas the front end people, maybe they are dealing with a lot of production issues, or particularly in the reverse, where like a front end person, okay, they have a bunch of time available, but like it can be difficult for them to write a front end when they don't actually have a back end to properly interact with. What this though is you can actually simulate that back end service as well. You can actually set up like a fake copy of it based upon this contract, and then it can allow like a front end developer to actively work, even if that back end developer is busy doing other things besides the development of that new service. So that's a very nice feature.
Is there a library or tool that facilitates?
Yes, so a good tool that I've, mostly in a proof of concept level, but a tool that I have used before though is Spring Cloud Contracts. So, and actually here, and I have this link at the end of this presentation, I do give an example of using Spring Cloud Contract. I put together like a little simple example on using it for developments. But yeah, there's another tool. It's been a little bit now, I'm blanking on it. That's also a bit more language agnostic as well, but I can't remember the name of it right now. Some additional tooling options. Also, like, as you're writing it out, like try to separate your unit test and integration test. Again, usually the way I define the difference between the two is unit test it would be all stuff that would be local to your system, whereas integration would be about stuff that's reaching out to some sort of external service. Again, even if you use it on a Docker container. But unit test, just because they're not depending upon some sort of external service, are going to generally be executing a lot faster. So by keeping them all together and having that executed in a surefire phase, which is also earlier, you can get some of that fail fast, behavior. Whereas, if you put them all together with the integration test, that can mean it can maybe potentially take a lot longer for your automated, that quick response to come back from. Also can provide some, isolation as well. And you can also use different class paths. So like by, separating it out, you won't necessarily bring in like all of like the test containers, class path or anything else you're using, which can also help with some performance. And that can be very useful if you start getting into a very large and robust automated test suite. So I was talking a little bit earlier. Keep forgetting I need to make a change. I had bytecode instead of bytecode. But how code coverage isn't always the best way to determine the quality of your test. So one problem with code coverage is all that is checking for is to see if some test executed that line of code. It doesn't tell you anything if that test is doing that correctly. So of course, if you write a test but you don't have any insertion in it, unless that test caused an exception to happen, you're quote unquote checking that code, but that code could still contain bugs and issues within it. So what mutation testing does is it can manipulate the bytecodes, like you got like an if statement. What it can do is like put a not at the start of that if statement, if there wasn't one, or if there was a not at the start of it, it can remove it, and then it will check to see if any of your automated tests fail. If no test fails, that means that mutation has survived, and then that's telling you that that code, even though you're testing it, isn't actually being checked well. And other things you could do is like a for loop, it could like, we're gonna do it till it's less than or equal to whatever number, like it may flip it around till it's greater than or equal to, or it just might be like, okay, is it less than and removes the equal to, or something like that. And again, it's gonna check to see, okay, any test fail when I make this change, and if none of them fail, that means that mutation lives, and that can tell you that maybe this test isn't actually covering this code as well as you think it should be. So and PID is the best tool. Like I've tried a couple of different ones. It's definitely the easiest one to use. Again, it's pretty much, it just works. One thing to keep in mind with this though, is that it's a very CPU intensive. So you wouldn't necessarily run mutation testing every time you're running your test suite. You would only, do it at something weekly or monthly or whatever it might be, because you wouldn't really probably need to be running this that often, but you probably would again want to have maybe some sort of regular interval run where you're executing the pit test or the mutation test, just to make sure your test suite, you're not accidentally, you're properly testing all the code. To your question earlier, Jim, when it comes to AI, yeah, there actually are a number of AI generated test tools out there. I haven't really worked with them. I only kind of became familiar with it because a couple of years ago now, for Casey Jug, like just had like some blind email sent to our Jug email saying like, hey, can we sponsor your Jug? And like it was from some AI company. I'm just like AI companies, kind of like Bitcoin companies and or stuff like that, CryptoCoin. It's just kind of like, I wasn't gonna respond, but one of my co-organizers did. I'm like, oh boy. So like they agreed that they're gonna test it or whatever, and they're like, oh, okay, or sponsor us for one of their months. And they're like, hey, can we do at least a presentation beforehand on our tool? And it's like, okay, fine, if you're gonna sponsor us, I guess, whatever. And kind of like the day before our meetup that month, I went out and actually like looked to see who this company was, and they did AI generated tests. And I'm like, okay, at least they're going to be covering something that at least our audience could potentially be interested in. I was worried it was going to be something that was going to be a tool that's going to be more pointing towards like C-level people or senior vice presidents, it at least was something that was relevant. So, it does seem something that can make sense, that if you write out some code, you could maybe point a AI tool, say like, hey, write a bunch of tests for this code based upon obviously this publicly available API. And it probably won't be able to, it's likely won't be able to cover all the test case, but hey, you can save about, covering all the basic test case and leaving it only the more advanced test case to you. That could potentially save you a good amount of time.
Yeah.
I haven't really worked with any of these AI test tools myself, and any more, like Claude Code, Absurd can handle that or shit. A lot of these tools already can be built in. You wouldn't need a dedicated tool for it.
Right, yeah, exactly.
Yeah. So one other tool, and I actually need to update this presentation to cover this. I was recently at a conference, and one of my friends, I attended his presentation, is property-based testing. And so what property-based testing is that, like based upon certain fields, instead of you manually writing out, like, okay, like let's say you have like a name field or something, or like a name field where you have like first name and last name and middle name and all that stuff, instead of like you writing out a bunch of tests like, oh, okay, Billy Korando and then Jim Bethcore and Scott Weisenheimer, instead of like you writing out a few examples like that, you can just write out different properties of like maybe what should be, min, max and different things for these different fields. And then this can put data through it, and to test to make sure that it's actually correct or not. And this can be really good, like a way to make sure that you're covering all the different edge cases without you having to manually test it. And then also kind of helps remove some of the potential biases that we have, like, because grew up in the US, in the Midwest and stuff like that, like I'm probably gonna use names I'm familiar with. But there could be, other names in other parts of the world that could also be users to my system. And I may not be, properly testing to make sure that those could also work. So for example, my wife, she's Mexican, and very common in Latin names to take their paternal maternal name, or they keep their paternal surname and then add on your marriage name as well when you get married or something. And it was just what my wife did. Though she, I think, actually kind of flipped it out from what it typically is, but all the same, like, whereas in my background, my family, like, you just take on like surname, you would only have one, you wouldn't have a hyphenated name. But that does two things, like for one, adds a hyphen, a non-alpha character into a name. Also, that greatly expands the length potential for a name. And there's also many other cultures where you can have a much longer names and stuff like that. So, that's just an example of like, but as I'm maybe writing out tests, I wouldn't necessarily think to include that for the test data. So, that can be some ways where you can bring in like much longer lists that are, cover maxes and mins, and bringing in other things as well. To make sure your tests are actually, covering those things, of course, if that makes sense for whatever you're doing. But yeah, definitely check it out. It's like something I wanted to play with. I haven't had a chance yet, but it's very good for kind of handling that, to push more data through your tests, just to make sure you're kind of covering all the edge cases. So yeah, some follow-up links, and I'll also get this follow-up link for JQuake also added in for property testing as well.
Look, quick theories as well.
Sorry,
Quick theories. Yeah,
Yes.
it's the other property based testing.
oh, okay, nice. Yeah, so, yeah, I'll include like at least the link to JQuake, at least that's the one I
It's
saw.
like about a day. The last release is like 2018. No,
That might be a bit old. Yeah, I'll put, also make sure I include a link to JQuake in here as well as a link to the presentation from my friend who gave that. Hopefully has one of those out there in an online location, that kind of goes through how that all works. Also, I guess, to the contract driven development, actually, this is a link to demonstrating that as well, if you're
Nice.
interested. Scott, you're kind of asking about that. But yeah, that's it. Actually, I need to remove Twitter. I'm not really on there anymore, but you can feel free to reach out to me at, again, my email, or also LinkedIn is also, I guess, a pretty good location. I'm somewhat active on there, so you can send me like a DM with a question, I'll probably get back to you, within a day, if not sooner. And yeah, any other questions then?
Yeah, just before you go, anything on benchmark testing?
Benchmark, like this performance testing?
Yes.
Not really. So performance testing, so like, like the automated testing, like it's a pretty hard pass fail. So like, if you get back a wrong result, that's really a fail. Whereas performance testing, it's a lot more gray. What's considered good performance for you, for your application, would be different maybe from an application I'm writing. So I don't really include that, just because it's also just an area that I'm like not that familiar with. Like that's like a whole different skill sets as well for developing and writing, because it's like, oh, okay, like, yeah, it makes sense to send 1,000 users in a second. I don't know, does it actually make sense or not? If it takes a long time to chug, is that good or is that bad? So I don't touch on that too much, at least in this presentation, just because it's a very different skill set. And what's considered valid or invalid is just going to be so context specific that I don't know if you provide any meaningful insight, just because also it's just a skill set that I've done some of it, but at any time I've tried to really do it, then like there's actual other like performance testing experts. I'm like, wow, I didn't even think about like, oh, making sure everything's really isolated and like, and all that stuff. That's just like, oh yeah, I wasn't even really thinking about that. I was just doing these things, though that's what I have sometimes happened upon a couple of performance issues. Which is kind of funny that we're kind of missed, so that was also like, oh, okay, I wasn't just being dumb, I actually did find something. But yeah, sorry, I really can't. I'm not, I don't have nearly enough expertise in that area. to
Yeah,
support
performance
it.
can also be very complicated. What are you talking about? We're talking about a distributed system. Or are you talking about,
Yeah.
a massive batch
I mean,
program that hits a database?
Yeah.
So there's a lot of different areas where performance can come in.
Yeah.
Yeah, also things like networking, so like, you can be like, oh, okay, I did a performance test in my application in our QA region, and then like, it looks great. But then you find out like the database is actually in that same physical building, where it is. Whereas in production, okay, it might be in the same region, but like it might be in two different buildings or, across the city or across the state
Yeah,
between
so
that, and then all of a
It's hard
sudden.
to
you're-
emulate, I think what you're trying to say, it's hard to emulate production environment, test
Yeah.
environment, it's very difficult.
That's
Yeah.
very true, but
And I'm not saying it's not
sometimes
possible.
you're looking at throughput, so that's a common matrix everyone wants to find out.
Sure.
And you take 1,000 requests per second, how and all that, that tells you how much you can scale for.
Yeah.
Or if you're scaling.
Right, but you also don't wanna overbuild, because it's gonna cost the customer a whole lot more,
100%.
so.
Yeah.
100%, so you can't start late if you overbuild. Yeah.
Yeah.
100%.
So, yeah, all it stays is that like, yeah, I just don't touch it because it gets. As complex as this itself, like that just adds like 10 layers and more layers of
But the
complexity.
standpoint is very logical, the standpoint is very logical, right?
Yeah.
It gets into systems architecture as well.
Yeah,
Yeah.
exactly, there's so many things, it's all about making sure, yeah, you're running on the
So why I asked that is that, basically, for my background, so here you guys go through a lot of processes, you build, you take your time. But back from Nigeria where I came from, oftentimes, you see, you just wake up and want to build an application in 3 months that took 5 years to build. Sometimes you bring all manner of unexpected demands or expectations that are not realistic.
So you talk about like an internet application?
But yeah, many times,
So, one of the common ways of addressing that is now using cloud servers and use auto scaling to address.
on local machine hype and, damage.
Like Kubernetes, like you use Kubernetes and use, horizontal pod autoscalers.
Yeah, so
Or,
let's say you run
um,
your machine, your web application on a single server. What we're talking about is there are ways that if demand increases, you can actually dynamically create new instances of that server.
Metascalers.
Yeah, auto scale.
I agree, but if you're not careful, then you're going to overplan, I mean, over budget and all that, so.
Yeah, that's true.
It's a very tricky, like I say, so I agree.
Yeah, any other questions? Yeah, I wasn't gonna give you a better answer, but yeah, it's just like a completely different area that I'm just.
Yeah.
I would do more harm than. Yeah. But it's like, I think I feel like I'd be more harmful than helpful than getting
Right,
anything
it's
more.
okay, I'll go and do my findings.
Huh?
I'll go and do my findings. No, it's not-
Oh. Yeah, any other questions then, or? No, okay, great, well, thanks for some.
Presentation.
Yeah, thank you.
Good stuff.
Yeah.
Yeah, very, very, very.
Very good, yeah. So do you find this topic to be very in demand these days?
Yeah, actually, this is a presentation that I've given quite a few times, like it's sometimes, like it's funny, like it ebb and flow, like, so as I mentioned, for like doing. These tours, like there can be some times where I'm doing this presentation at every single jug that I'm going to on a given tour, and then sometimes it might be, I think it's maybe been a month or two since the last time I gave him this presentation, so it ebbs and
Demand
flows.
fluctuates.
Yeah.
Demand fluctuates.
But like it always remains pretty consistent, just because again, automating testing is gonna be something that's gonna be at least somewhat relevant to. Every developer, you're gonna at least
Sure.
hopefully care at least a little bit about it or not. And I think it's also maybe trying to address again some of the stuff that like, again, like that doesn't just rely on best practices or something like
So-
that there provides some more substance as to why this is actually really useful.
Yeah, so question, have you actually read or looked at any of the research done by industry or universities on cost benefits to doing automated testing? Is there any kind of research in this area or?
Oh,
is it
that's
all-
right.
The
The cost of automated testing? or-
well, cost benefit.
Cost
So-
benefit, okay.
Yeah, so
Got it.
doing automated testing actually increases overall, or decreases overall cost of ownership. of-
Right, yes.
Yeah. I think I've done that like a couple of times, like maybe a little bit like, reading through it, a little bit of like research and studies and done on it. I think some of that stuff is kind of like also the like for like the cost of a bug, increases by like an order of magnitude for like every step. Like if the developer catches it as of writing it, it's like a lot cheaper versus QA catching it versus it getting to production.
And that was very true, especially back in the days when we did
Yeah.
waterfall approach.
Yeah, very much so, yeah.
I mean, the exponential cost is, a steeper curve now with, CI and CD.
Yeah.
The cost is a lot less.
Yeah, especially, yeah. Pushing, deploying to production is a lot easier these days than it was, back when like I got started, let alone back.
I'm talking the night.
The '90s, yeah, let alone back in the '90s where, and of course, also it would vary depending upon if you're doing stuff like hardware and embedded, like. Sure, the cost of bugs become a lot more expensive because you would maybe have to really coordinate with customers to get that stuff updated versus like.
Yeah, I mean, even like, growing up, Nintendo games never had bugs.
Yeah, yeah.
But how much testing did they have to do before it shipped?
Yeah, exactly.
I mean-
Or sometimes there are infamous bugs for things, I just remember that it wasn't actually a bug, so like one of the games I played a lot growing up was Grand Theft Auto San Andreas, and there was one mission where you're flying around in like a little RC airplane and you're having to blow up people because of course it's Grand Theft Auto, but like it has like a little fuel gauge, and I get to go and like blow up like 3 or 4 different couriers and get back to your base. And it's also gets so frustrating. It's like, oh my God, it's just like a little RC airplane. If I don't get it back, why does it matter? Why does it make this a bill? All it's saying the same is they just had a bug where they just didn't give you enough fuel. And so it made that mission nearly impossible to complete. Like I remember after like the 100th time I did, I finally completed it, but it was way more difficult than they intended to be. It was like by far the most difficult mission in the game.
Wow.
So, some of those bugs did happen, and granted it's a game, so it's hard to say there's a real cost comparatively towards, like some
Frustration.
business application, but it did cause plenty of frustration for.
I did it.
Exactly.
One thing you could add to this presentation is how to avoid writing brittle tests.
Yeah, that would be, something good to avoid, yeah, yeah.
But for me, it's interesting to note that the evolution of software has brought about more complexities and also more bugs. So back in the days when we had full stack, we did about front end, back end, UI, UX, DPA, QA. We had less, but now have multiple layers, regressions, different teams. Somebody comes and just renames the variable, the whole thing breaks and all that. Really, it doesn't.
Yeah, no, that could be a good thing to add on how to avoid, writing, brittle tests could be good, yeah. Yeah, anything else then, or?
This is really cool.
Yeah, appreciate it, again, appreciate all the
Alright,
questions,
it's
it's
great.
obviously nice that.